right, reference angles, we did it with degrees. Now we're going to do it with radians. The positive acute angle formed by the terminal side of the angle and the x-axis. Very similar to what we did with degrees. So let's just kind of label our quadrants. If it ends up in quadrant 1, your reference angle is just going to be theta, right? It's whatever that measure of the radian is. If it ends up in quadrant 2, before, remember, we did 180 minus the degrees, but 180 on this radian circle we represent as pi. So we would do pi minus theta, or pi minus our radians. But you'd have to get that common denominator. You know, it's fine. If it ends up in quadrant 3, before we did our theta minus 180 degrees, but again, we're representing 180 degrees as pi here. So we would do our theta minus pi. And then quadrant 4, before it was 360 minus our degrees, but 360 degrees we are representing as 2 pi. 2 pi minus our radians. All right, let's try it out. Pi over 6. Think of where that would end up. So if we had 2 pi over 1, we turn that into 6. That would be 12 pi over 6 for one full rotation. So this would be 12 pi over 6. This would be 6 pi over 6. This would be 3 pi over 6. And this would be 9 pi over 6. So our angle, pi over 6, wouldn't even make it all the way to 3 pi over 6. So that would be our reference angle. It ends up in quadrant 1, so it's just equal to whatever our angle is. Pi over 6 is our reference angle. Now if we are in thirds here, 2 pi over 1 represented as thirds would be 6 pi for a full rotation. So let's see, 6 pi over 3, 3 pi over 3, you know, 1 half of that. Okay, we'd have to represent it in 6, but we're fine. So this would be like 1.5 pi over 3, which you could represent as 3 over 6 pi, but we don't want to start messing with changing denominators for this. But look, one full rotation would get us to 6 pi over 3, and we need just a little bit more. We need 7 pi over 3, which will end up right there. Now, we have that full rotation, so we're going to have to actually subtract one full rotation off of that. So 7 pi over 3 minus one full rotation would be 6 pi over 3. 7 pi over 3 minus 6 pi over 3 just leaves us with pi over 3 for our reference angle. And one more. Still got time. 9 pi over 4. So we're in fourths. So one full rotation would be 8 pi over 4. And I'm at 9 pi over 4. So it's going to be more than a full rotation here. 8 pi over 4. Half of that would be 4 pi over 4. Half of that would be 2 pi over 4. And here would be 6 pi over 4. So let's do this one in blue. We got one full rotation for 8 pi over 4. And we need 9 pi over 4, which will end up right here. 9 pi over 4. But again, we need to subtract our full rotation. So 9 pi over 4 minus a full rotation, which is 8 pi over 4, leaves us with just pi over 4 as our reference angle. Let's get at that homework and try some of these out, dude.